Welcome back. In this chapter, we'll see how to send messages to a message broker using Spring Boot. If you've already done messaging before, then I recommend that you do watch the short section of this video from about 6 minutes to 15 minutes, where I'll be describing how we're going to use messaging on our microservice architecture. Apart from that, the rest of this video shows how to use Spring Boot to send messages to Apache ActiveMq. Messaging is a really powerful tool when you're architecting microservices, and I think for our vehicle tracking application, it's going to have a very useful purpose. For some reason, I've never managed to get around to covering how to work with messaging on Spring in any of our previous courses. It just kind of fell through the cracks, really. So I'm sorry about that, but we have covered in other courses how to use JMS. That's the Standard Java Messaging Service. We have a standalone Messaging with JMS course, and we've also absorbed that content into our new series of Wildfly courses. So I guess that many of you will already have some experience of messaging, but for those of you that haven't, let's do a quick overview. You'll be familiar with the traditional way of calling code, the synchronous way. That's when we have a caller, this might be a method in a class, calling another method in another class. When the caller makes the call, it effectively waits for the target to complete its processing. The caller here is now blocked, and only when the target has completed does the caller continue. And of course, we can extend that. The target could be on a different physical machine, and this might now be a web service, but the calling of this remote web service would be synchronous as well. To contrast, in an asynchronous call, the difference is once the caller has called the target, the caller can then continue with what it was doing. So even if the target takes an hour or whatever to do its processing, the caller can carry on with what it was doing. Now, asynchronous is not the natural model to use for sort of regular day-to-day work. If you're doing normal method calls, then synchronous is normally what you want because the caller usually wants a response. It wants an answer. If you're doing this asynchronous way, then it's going to be much harder for the target to pass some kind of a return value back to the caller, because of course the caller, by the time it gets a response, may well be in a very different state. It is possible to do this, and we will be looking at this on some future courses. But on this course, when we're using asynchronous calls, we're interested in what I'm going to call fire and forget calls. And this is where the caller makes the call and then doesn't care about receiving a response. It is, if you like, going to trigger a process on the target, but the caller doesn't need to wait for the results. And there are several ways to implement this. For example, we could set up some kind of threading here on the target. But on this course, we're interested specifically in messaging, and that's another very common way to implement asynchronous calls. And you're all used to sending messages in real life, so messaging's actually quite a simple metaphor. The caller is going to send a message to the target, and once that message is sent, the caller can carry on with whatever it was doing. The target, when it eventually receives that message, will do some processing around it in response to receiving the message. So how do we do that in Java? Well, Java has had a messaging API for many years now. It's been around since around 2001. And it's a really robust API, and it's very well respected. It's actually part of the Java EE libraries, so you don't get it in your standard Java. And what Spring have done is they've decided that they will allow us to really easily integrate JMS into any regular Spring application. And I'm going to be showing you how to do that in just a few moments. But before we do that, I want to look at why is messaging so powerful, and especially for this course, why is it so useful in a microservice architecture? Well, the big thing with messaging is coupling. We're going to find that messaging allows us to reduce coupling dramatically. And I'll illustrate that with a real example, the practical work that we're doing on this course. Back in Module 1 of this course, we built a very basic vehicle tracking application. If you haven't done Module 1, then don't worry. I will be giving you all of the code from that module in a few moments, but I will be assuming that you know how to use Spring Boot. That module was very basic. We can simply enter the details of a new vehicle that we want to manage. We can list the vehicles in our system and so on. It was basically a CRUD application, but it was a useful one to get us started with Spring Boot. By the way, if you have just come straight to this course, I have to warn you, the look and feel of that CRUD application was very basic, very poor quality web pages, because web design wasn't the point of that course. It allowed us to illustrate the concepts. But on this course, we're going to do a much more interesting requirement. We want to be able to track the current positions live and in real time of all of the vehicles in our fleet, and we want to be able to show them on some kind of a map. We need to think about how we're going to architect this. And the simple way of doing this really would be to add maybe a REST interface to our existing application, and then the remote vehicles that are maybe running an Android device or whatever, they could then, let's say every second, call the REST interface synchronously with its current position. That's the easy way. But we're not going to do it like that for at least two reasons. And first of all, well, that's going to be a monolith. And as I talked about in the first chapter, I don't want to do a monolith. I want to keep the web application just doing the web side of things. If we add into here position tracking, well, that's just going to make it bloated. Now, it will be okay for the web app to display the map and display the positions, but I don't want it to be gathering and storing the position reports. But even if you're not going to do a microservice, there's another reason why doing it like this with synchronous REST calls is not a good idea, and that's because of the coupling that's always involved when you're doing synchronous calls. For a synchronous call to work, both the caller and the target have to be up and running and available at the same time. If for any reason this web application goes down, then the remote vehicles, of course, well, they're not going to be able to communicate with the server, and therefore we're going to miss some positional reports. So it might be that the web application comes back up again after a minute of downtime. Well, that means we're definitely going to have lost 1 minute's worth of positional data. Now, that might not be a problem. It might be that we don't care if we miss big chunks of data. This is going to depend on your system's requirements, but I want to make it a firm requirement for this system that we aim, if possible, to lose no positional reports ever. Perhaps it's a regulatory thing. Perhaps we want to make sure that the lorry drivers aren't going for joyrides in the evening or something. So what can we do? Well, by using messaging and by some careful design, we can get closer to our aim of never losing a message. In JMS, the Java messaging service, we have the concept of a message broker. This is a standalone application, but it will be third party. It will be something you either buy or you download from open source. Now, back in the early days, like 2001, you did indeed have to buy these message brokers. They were very expensive pieces of software. But these days, there are some very serious and well implemented open source implementations of brokers, and we'll be looking at one in just a few moments. These brokers are designed to be extremely robust. You can expect very long uptimes from them. The job of the broker is to hold message queues. A few moments ago, I said that the caller sends a message to the target. Actually, that's not true. In fact, the caller sends a message to the broker. And that's great because it means that the messages are effectively being kept in a safe place. But the huge benefit is that if the server is down, as long as the message queue is still up, then that's fine. The vehicles can still send their positional reports and they'll just get held in this queue temporarily. Once the server comes back up again, it will catch up with the processing and it will read all of the messages off the queue. Now, the problem here is that, of course, you do need to ensure that your queue has an extremely high uptime, as close to 100% as you can get. Obviously, if the queue goes down, then we've got a big problem. And we're really back to the problem that we started with then. The vehicles will not be able to communicate with the server. So what we typically do here in production is we ensure that we deploy the message broker to its own separate physical node so that it's isolated from the server that you're deploying your code to. And you would make sure that this is some kind of clustered system. And it will be common to have several nodes running the message broker. And if one crashes, then another one can step in. Now, we won't be worrying any more about that, the deployment of the broker on this course at least, but just be assured for now at least that it's much easier to get high uptime on a message broker than it is for a server running a general application. As an example, here at Virtual Pair Programmers, for our systems, we use the Amazon Web Services, and they offer a hosted queue service called SQS, the Simple Queue Service, and you automatically get it deployed to multiple nodes. And we might look at how to do that in a future AWS module. So with that in mind then, the architecture that I'm planning for us to build here is that we're going to leave the web application almost untouched. We will add in the map display, but that's just a new web page. But for the code that's going to gather the positional reports, well, that's going to be our first microservice. Its job in life will be simple. It has to take the positional reports and store them in its own private database. Now, that's all we're going to do on this course, but you can probably see that the microservice would probably do a little bit more than that. It might do things like calculating to determine if the vehicles are speeding and that kind of thing. Now, we need to make sure then that we don't lose any positional reports. So we're going to deploy a separate message broker, and that will decouple the vehicles from the microservice. The vehicles are just going to send to the queue on the broker, and they're going to be firing and forgetting these reports. Our microservice here, when it's running at least, will keep reading from the queue. And by the way, it's worth mentioning that especially on a microservice architecture, you are going to get downtime of the individual microservices. It's a necessity. For the microservice that we have here, of course, we're going to be doing lots of redeployments as we're upgrading the software, and that's going to mean downtime, even if it's only for a few seconds. But we don't want to lose any messages, so that's fine. When we're redeploying, we might see a few messages stacking up in the queue, but they will get dealt with once the redeployment's complete. There are other things we can do to minimize downtime, but queuing is a great way of doing it. Now, I hope that makes sense. It gives us a basic design. There might be better ways of designing this system, but it's certainly going to give us plenty to think about for this course. So where do we start? Well, the obvious place is to get ourselves a message broker. And one of the most popular message brokers for many years now has been the Apache ActiveMq project. ActiveMq is an excellent implementation of JMS, as you can see here. Getting hold of this is really simple. You just need to get to the downloads page and download whatever the latest release is. At the time of recording, it's 5.14.0. So I just downloaded off camera. If you're on a Linux or a Mac-based operating system, then it really is a simple case of unpacking the distribution to anywhere sensible. As we're developing, it really doesn't matter where you have it. And then go into the Apache ActiveMq directory. And then there is a bin directory. In there, there's a script called ActiveMq, and you simply need to feed it the parameter start. Now, for Mac and Linux, by default, you won't see any log files when you've started ActiveMq. You'll find the log in the data directory, which is one level up, and then you should find a file in there called activemq.log. And I recommend for the course that you do a tail-f on that file, and then you probably know that will constantly output to the console. If you're on Windows, then it's even simpler. Again, unpack the directory to anywhere you like, find the bin directory, and then be careful here. I think if you run the activemq.bat script from here, you'll probably see a crash. I don't know if you noticed the window open and close really quickly there. You need to run the appropriate scripts from either Win32 or Win64, depending on whether you're on a 32-bit or 64-bit operating system. I'm guessing you're probably on a 64-bit operating system. From there, run activemq.bat. And the difference with Windows is that you will see the log output to the console. Well, whichever way you've done it, there's a lot of rubbish in this log, but the interesting thing that we're looking for is an info line saying that the ActiveMq web console is available at, and it will be giving you an address which is probably localhost, and you're looking for the port number here. The default is 8161, and I expect that will be the case for you, but you might just want to double check that port number. We can now switch across to a browser and visit localhost, in my case, and I guess yours, 8161, and you should now be in the ActiveMq administration console. We're going to follow the link here to manage the ActiveMq broker, and you will be now prompted for authentication. Because we're running in development mode, we don't have a strong username and password on here. Of course, in real life, when we deploy this, we will. But for development, it's fine to use the default, which is admin, and exactly the same password of admin. And I hope that worked for you. Now, the first thing we can do in here is we can click on the queues link, and that will give us a list of all of the queues that have been configured under Apache ActiveMq. Well, of course, this is a fresh installation, so we don't have any queues just yet. But creating a queue is such a simple operation. We simply type in the name of the queue that we want in here and hit create. Now, for this course, as you know, we're going to be receiving position reports from lorries all over the world. So we're going to call this queue position queue. Of course, you can call that anything you like, but you will need to remember what you've put in there for the code later. Click on create. Now, we're going to be writing some code very shortly to interact with this queue. We're going to be sending messages to and from this queue. But before we even do that, we can play around with this queue using the console. There's a link here over on the right-hand side, send to. This will enable us to immediately, without writing any code, to send a message to that queue. And so you can immediately now see the structure of a JMS message. There's two parts, a header and a body, just like an email, I guess. I'll let you have a look at some of the things that are in that header. We don't generally have to fill in these fields, but there are some useful fields such as priority and time to live. I don't think we'll be doing that on this course, but you can assign priorities to messages and you can give them an expiry. But the interesting thing we're looking for is the body, and this is going to enable us to send a text message, which is one of the message types supported by the JMS API. And, well, yeah, it's just text. I don't really know what to say, really. I'll say this is a test text message. Put anything in there that you like, and then click on send. And now you can see that on the queue, there is a one pending message. Now, before we write any code to read from that queue, we can have a little peek at the queue by clicking on the queue. We'll get now a full list of the messages. There'll be a generated message ID, which will be a long string, probably containing your machine name. There's its timestamp, and we can click the link there, and we can have a little peek at the contents of that message. Now, that's really just for fun, if that's your idea of fun. But in general, we wouldn't be using the ActiveMq console to look at the messages. Of course, we need to write some code to do that. So it's time now to have a look at the JMS API. Well, although I do like the JMS API, there's no doubt that working with the JMS API is anything less than pleasant. I'm stealing here one of the captions from our earlier JMS messaging course. And the caption that we have here is, believe it or not, the code that we need just to send a single message to a queue. There is a lot of plumbing work involved here. And, well, I'll let you read it for yourself rather than plowing through all of it. There's a whole mass of connection factories and connections and sessions. And, you know, I've been working with this API since I think about 2002. And even today, with my experience of JMS, I often still have to look up what all of these steps really mean. There's a line here, for example, where you're getting hold of this session object, which is kind of the object that ultimately allows you to send to the queue. And you've got to pass in a couple of parameters here, which are very difficult to understand. They're very opaque. Anyway, you're a Spring developer, and I think you know the score by now. One of the purposes of Spring is it's going to clean up all of this boilerplate code and reduce everything down to just its bare essentials. So for this course, I'm not going to worry about any of this plumbing, but do check out either our Messaging with JMS course, or we have a Wildfly module where we do this raw, low-level JMS work. As Spring developers, we can forget all about that and concentrate on the code. So I think what we'll do is we'll switch across now to Spring Boot. We'll start a brand new project, and we'll make that project be able to send a message to our queue. A little bit like we did on the first module of Spring Boot, I'm going to start the project by using the Spring Initializer, but as you know, you don't need to do that. You can just create a regular Maven project with the Spring Boot starter in the POM. But I'm going to jump start it with this. The group is going to be com.virtual pair programmers, anything you like in there. And the artifact here is going to be message testing. And for the dependencies, I'll switch to the full version. At the time of recording, the JMS dependencies are quite a long way down the page, under the I/O section. And you'll see there are several options for JMS. And the differences between these are just the different implementations of JMS that you want to use. In other words, you're going to get a different collection of jar files depending on which one you choose. We're going for ActiveMq, and really that's the only dependency we're going to need on this project. So as usual, we can generate that project. That's going to generate a zip file which you can extract into your Eclipse workspace. And now I'm in the workspace where I extracted that folder to, exactly as on the first module of this training series. We'll just create a new project by going File, New Java Project, and the project name needs to be exactly the same as the artifact name that we just used. So that's message testing. And the first thing I'll do is run the Maven build, and we'll use Eclipse : to download the jar files and generate the correct class path for Eclipse. Okay, so now that's done, I should be able to refresh this project, and now all of the code is compiling. It's worth a little look at the build path, I guess. Just in case you're interested, we can look at the libraries there. We should be expecting to see lots of ActiveMq jars, and there's a few of them just there. So then, the point of this exercise is to see how easy it is to send and receive messages using Spring Boot. But I really mustn't forget that it's also easy to do this in Spring Framework as well. Of course, using Spring Boot, we're avoiding the need to have to do any kind of configuration, whether that's with Java config or using XML, whichever you prefer. Using JMS in Spring Framework is great, but there is a little bit of plumbing work to do before you get things working. But as is par for the course with Spring Boot, all or most of the configuration work has already been done for us, so we can get straight on with the code. Now, as this is going to be a very simple testing application, we won't bother being production standard just at this stage, just for speed. I'm suggesting that we go straight into the main application Java class, which you'll recall is under the source main Java folder, and then in whichever package you initially declared. So that's the @Spring Boot application class. And what I'm aiming to demonstrate here is that Spring have simplified JMS using its usual approach that you will have seen all over the place in Spring, and that's using a template. You'll not be surprised to know that there is a class called JMS template, and it's through this that we're going to do all of our sending and receiving. Now, this object will have already been created for us in the Spring application context. And my usual technique for just getting up and running quickly with this, before long we'll have created a proper component class and we'll be able to do auto wiring and so on into it. But we're not quite there yet. So I often, when I'm just doing quick testing like this, I directly talk to the Spring application context rather than doing any kind of auto wiring. So I don't know if that makes sense, but I'll demonstrate that I can get this JMS template object by calling the Spring application contexts, the regular getBean method that I'm guessing you'll be familiar with from standard Spring Framework. And the parameter into that method, well, I need to know either the name of the bean that I want or the type of the bean if there's only one of them, and there will be. So with JMS template.class in here, I'm going to get hold of that JMS template object. And of course, I have a compile error here because I don't have visibility of the Spring application context, but that's really easy to fix. Now, I cannot remember if I mentioned this in part 1 of our Spring Boot series, but I can tell you now at least that the run method here in the Spring Boot application class will always return you a reference to the Spring application context, just in case you need it. So we can grab hold of that object, and its type, well, as usual, it will be application context. And if you fix up your imports now, just in case you haven't done a virtual pair programmers course before, I did a Control-Shift-O there. It would be Command-Shift-O on a Macintosh. And this is a really exciting point because once we've got this JMS template object, now what we can do with this JMS template object, well, as usual with all of these Spring objects, there's a huge list of methods in here, and we can really get quite deep and dirty with the JMS API through this. But one thing I want to show you on this course is that if you're doing sort of regular, normal requirements, you don't need to get that deep. And the calling procedure is really simple and straightforward. There's a method in here called, I need to go up to the top, convert and send. And as you can see from the IntelliSense here, it takes an instance of the object representing your message. Now, in fact, that version works if you set a default destination. You can see here there's an alternative version which takes in an instance of type destination. Now, destination just means, for us, the name of the queue that you're sending to. Well, actually, that's an object representing it, but there is a version here which just takes in a raw string for the destination name. And that's the version that we want because we don't have a default destination yet. Well, it's been a while now, but you might recall that we've created a queue called position queue. And the second parameter here, well, this is an interesting one. This can be any type of object. But what Spring's going to do, depending on the type of object that we put in here, it's going to try to convert it to a JMS message. Just in case you've never seen JMS before, I'll very quickly tell you that there are different types of message supported by the JMS API. And I've got some of the main ones up here on this caption. The simple one is the text message. That's easy. The body of that is a string. And that's what we just sent earlier on the ActiveMq console. But text messages can be a little bit too basic. If you need any kind of structured data in your message, then you might want to choose one of the other types. And for me, a very common one that I work with is the map message. A map is a collection of key value pairs stored inside the body. It feels very much like a Java hash map, although it isn't a Java hash map. It's a JMS map message, a very different structure, but a very similar idea. Now, map messages are going to be bigger in their size than a text message, so I would recommend that you go for a text message if you possibly can, if it suits your requirements, because you really want to get these messages as small as possible for performance. But map messages will certainly do the job quite well. The other possibility is you could go for an object message, which takes a serialized Java object. Now, I personally have never used that type of JMS message. I think it's a little bit worrying. The messages can get too big if you go down that route. But it's worth mentioning that it's there. You might possibly find it useful. There are some other types like bytes message and stream message, but for me, text message and map message would be the main two. Now, if you were working with the JMS API directly, then you would have to do some work to create whichever type of message that you're trying to send. The clever thing about the convert and send method is that Spring will automatically, based on the type of object, Java object that you pass in here, it will automatically convert to the corresponding JMS message type. So, for example, if we have a string in here, then Spring will convert that into a text message. And brilliantly, if you pass in a regular Java hash map, or I should say really any map, but a hash map, for example, then it will automatically convert it into a map message, which is absolutely fantastic. Now, I've not done any thought here about resource handling or dealing with problems or anything like that. Of course, we'll think about that shortly. But for now, what we have here is a complete block of code that should send a message to our ActiveMq queue. Well, there is a little bit of configuration that we do because by default, out of the box, Spring Boot will think that we're sort of in local development testing mode, and it will automatically create an embedded ActiveMq broker running as part of your application. And that's an excellent feature because it means that if you're developing a microservice and you want to concentrate on the microservice and you don't want to set up an external queue, then the fact that Spring automatically falls back to an embedded queue means that you can develop locally without having an external queue running. Because we're diving straight in and we're going to set up the full microservice architecture, we're going to use this remote queue, but definitely worth bearing in mind that if the queue's not there, Spring will always fall back to an embedded broker. Therefore, your code won't crash, it just won't be writing to an external broker. You'll notice here I've switched to Windows because I had some problems with my screen recording software, but of course, all of this applies to Linux as well. So we need to point our application at the ActiveMq broker, and that's easy to do. We're going to go into the application.properties under the resources, and we're going to add in a simple property which points to the remote URL of the broker. The property name is spring.activemq.broker-URL, and that will be set to the URL of the remote broker. Well, of course, we're not really remote. We're running locally. And if you dig through this logging, it's not that easy to see in the ActiveMq log, but I can tell you that buried in here somewhere is the URL that we're looking for. There are four separate listening for connections logs. We're just going to focus on the first of them, the TCP version. The TCP version is the regular method of connecting to a JMS broker using TCP. And the important thing I'm really looking for here is the port number, which is 61616 by default. It's easy to get confused here because earlier in our work we went for the ActiveMq administration console. This is the web front end of ActiveMq. Remember, that was 8161. But here we're looking for the port number for the queue itself. Very different, 61616. Now that's the default. It has been the default for many years, so I expect it to be the same for you. This here, of course, is just the name of my computer. Really, that means localhost. So we're looking here for TCP://localhost:6161:6. Now, one thing to be aware of here, I did mention this in the first module of Spring Boot. The default when running directly under Eclipse, which is what I want to do, I don't want to generate a jar file or anything. If I look in the build path and configure build path, under the source tab, the default setting is that currently excluded from the build path under resources are all application.properties files. Now that's not what we want. We do want to include application.properties on the class path, otherwise this won't be picked up. So a quick fix for that is I can click on that and click remove, but the problem with that is that will be regenerated if you rerun the Eclipse:/Eclipse Maven goal. So as a permanent fix, we can go into the pom.xml file, go down to the bottom build tag, and after the plugins tag, we're just going to add a few tags into here. We need the resources tag, inside which we have the resource tag, and then in here we have filtering set to true. And for the directory, this is the location of this is src/main/resources. And then we have includes, and then an include tag of, well, I'm going to go for star.properties. I guess later on we might use other types of file like YAML files, but that will certainly do the job for now. And I'm going to double check that that's worked by running the POM as a Maven build. Again, Eclipse:/Eclipse. And then I'll refresh the project and then check the build path inside Eclipse under the source tab. Yeah, we've now got an included star.properties. So, although this is not production standard code yet, I must absolutely emphasize that, I think this should send a message to our queue. So let's give this a run, see what happens. Okay, well, the usual Spring Boot logging, and nothing particularly exciting has happened. Notice that the application is completed. You might be used to doing web applications using Spring Boot, which of course will keep on running forever. But because we don't have anything that's running forever in this project, it will have hopefully just executed this code and then completed. Well, if we now switch across to our ActiveMq console and give this a refresh, this looks pretty promising. I've got 2 pending messages now in this queue. And although we wouldn't normally do this, we can have a little peek inside here. And I'm working off the timestamps here. This one at the bottom is the latest one. And there's the message that we just sent from the code. So I don't know how excited you are by this, but if you've had to plow through JMS code in the past, this is quite a luxurious way of working. Just in case you haven't done JMS before, I want to talk about a few aspects of the JMS API. And one thing that's already caught my eye is this column here, which is mentioning persistence. Now, the message that we sent earlier through the console itself, notice that is set to non-persistent, whereas the message we just sent from the code is called persistent. Now, persistency is all about simply, if the broker were to be stopped, and I can do that easily, of course, in Windows by killing the window. In Linux, you would rerun the ActiveMq script again, but this time with the parameter stop, and then restart it. Well, I'm sure you can guess exactly what's going to happen. We've lost the non-persistent message from the queue, whereas the persistent message is still there and has been restored. Now, the default when we're sending from our code, as you've seen, is that we will get persistent messages. And I would suggest that is usually what you want. One of the things we're looking for with message sending is that once a message has reached the queue, we want to be absolutely sure that one way or another, eventually it's going to get consumed and processed. Now, of course, once we've sent a message to a queue, the queue might crash, the queue might go down for some reason. And we generally want to be sure that when the queue comes back up again, any previous messages are still there. So the default is persistent. I don't know why, but when we send a message through the console here, it makes it non-persistent. There is, of course, a performance cost in making your messages persistent because it has to store them to disk somehow. But that's just the price that you pay. If you're writing a highly performant, high throughput system and you don't mind if some messages might get lost, then you can change that default through the API. And really, that's it for sending messages. Now, you might be thinking that we have to do some kind of cleanup work when we've finished working with this JMS template. It would be usual style if this were a standard Spring Framework application to close the application context to make sure that any destroy methods are run on the beans such as JMS template. But Spring Boot's got our back here. If you check the console very carefully, you can see that without us having to do any particular work, we are seeing that the application context is closing and that the beans are being stopped and general cleanup work is going on there. And you might then think that, perhaps we still need a try finally block in case there's a horrible crash in the middle of here. But even in that situation, and I'm going to simulate this by doing throwing a new null pointer exception. Not good style, of course, but it's something I'm going to do quite a lot in this chapter. Actually, because that's now unreachable code, I think I'll do this after sending the message. But that should still prove the point that even with a crash before we've reached the end of the main method, and there is the crash, we are still seeing that the application context is being closed. So if you have any worries about things like network connections being held open, there's absolutely no problem there. That will mean, of course, if we go to the queue, we now have another message on the queue, because even though we had a crash, once this send method has run, we can assume that the message is successfully on the queue. It's worth mentioning what would happen if for some reason the queue has gone down and we try to do a send. Well, in that case, we're going to get an exception thrown. Now, that exception is of type uncategorized JMS exception, which always disappoints me a little bit. I wish it was something that explicitly said broker unavailable exception or something like that. You can kind of see from the underlying causes that it's clearly because connections have been refused. But I'd like you to keep that in mind because that is going to become relevant a little later on. If you've been following along with me there, don't forget to get the broker back up and running. And then we can probably do another send. All good. So that's it for sending. I think it's time to take a break. And in the next chapter, we'll look at the other side of the equation. We'll finally get some receiving of messages. I'll see you then.